So far in this chapter, we've taken a look at three different methods to calculate the equation of a line. Today we're going to take a look at a fourth method called linear regression. Linear regression uses the data to determine a model or a linear model that fits that data. Now, in order to do this, we're going to use our graphing calculator, so have your graphing calculator available. Let's run through some examples and show you the keying sequence on your graphing calculator that you'll need in order to calculate the line of regression. From your graphing calculator, you're going to press the Stat button, which is right here in the middle. And then you're going to press Enter where it says Edit our statistics. In list 1 here, we're going to enter in our independent variable, which is the number of months this stock has been increasing. So you can see that I've gone ahead and done that. I've entered in the numbers 1 through 8. You can do that now. Next, we're going to cursor over to list 2, and we're going to enter in our dependent variable, or in this case, the stock prices. Go ahead and do that now. Okay, now that we have our data entered into list 1 and list 2, we are going to go back to the Stat button and press Stat, arrow over to the Calculate menu, and cursor down to number 4 where it says Linear Regression. I'm going to go ahead and press Enter once, and then Enter again a second time, and I'm going to get my model that fits this data. So you can see it's going to take on the form y equals ax plus b, where a has a value of 3.9 and b has a value of 26.7. So I'm going to go ahead and write that in here for my line of best fit. So here's the equation that fits this data. You can see that I have a slope of about 3.9 and a y-intercept of 26.7. Now, these other values down here, r squared and r, are called our correlation coefficient, and they tell us how closely this line predicts the data. The closer you are to positive 1, the better this equation is to predict that data. Okay. Part B of this asks us to use this equation in Part A to predict the price of the stock in the 16th month, which means X needs to take on the value of 16. So let's find Y, our stock price, in the 16th month. A great way to do this from your graphing calculator is to go into your Y equals now, press Y equals, and then come over to Variables, this key V-A-R-S, press Variables, come down to Statistics, press Enter, and we're going to go over to our equation line. To our equation line, which is EQ, and we're going to press Enter on regression equation. Once we press Enter, it's going to automatically put our regression equation into the Y1. Now I can go to my table, and I can scroll down to the 16th month, and I can see my stock prices, and that 16th month look like they should be about 89.16. which should be the same value that you get is if you were to evaluate this equation for 16. So in the 16th month, we're going to say that our stock prices should be at 89.16. All right, let's take a look at another example and become a little bit more familiar with how to enter in these values into our graphing calculator. In example 2, we see Jennifer and Barry they're running an ice cream shop. They gather some data over the weeks, the number of cones they sell, the daily high temperature. They want to know if there's a linear relationship. So we're going to plot the data over here at the right, so you can go ahead and plot those points. Next, we're going to find a regression line for the data. So let's go back to our calculator. We're going to press Stat and then Enter to edit our lists. Now, both of these lists need to be cleared, so you can do that by cursoring up to L2, pressing Clear, and cursor down. Cursor back to list 1, up, highlight L1, press Clear, cursor down. Let's go ahead and enter in our two lists. Now that we have our two lists entered in, we are going to go back to the Stat, cursor over to Calc, and come down to number 4, Linear Regression. Pressing Enter once and then twice, I'm now going to get my model that fits this data. Let's go ahead and write that regression line in on our line. And that would read as such: y equals 103.9x plus a negative 7,102.3. Find the slope of the regression line and explain what it means in the context of the problem. So we see here our slope is 103.9. So that means that there's approximately 104 cones that are sold as 1 degree increase in temperature. So cones sold per 1 degree temperature increase. All right, now how many cones does this equation predict? They will sell on a day of 85 degrees. So again, we can use this equation to substitute 85 in for x, or we can go back to our graphing calculator and see if our graphing calculator can quickly gather that for us. So I'm going to do that on a calculator by going to my y equals. I'm going to clear out the equation that's in there already, and then I'm going to press variables over to statistics, over to equation, regression equation, and now I'm going to go to my table. Now I want the degree of 85, but I see that that's going to take me a long time to scroll down there. I can do this a quicker way. If I go to second function, table set, I can set my table to start at 85 degrees. Now when I go back to my table, I can see it starts here at 85, so it looks like it's going to predict that I will sell 1,732 cones. So let's go back, we'll write that in, 1,732. All right, one final example for today, and again we're just going to get practice entering in our equations. All right, one more example for today, and again we're just going to get some practice with the keying sequence on our graphic calculators. So it says the table at the right shows a life expectancy and annual per capita per person income for 10 countries in South America. We want to graph that data below, and we want to find a regression line. So what we're going to call as our x variable is the income, and our y variable is going to be the life expectancy. So we're going to use our graphing calculator to come up with the regression line for this data. So let's go back to our graphing calculator. We'll hit stat, enter on those lists. We're going to clear out list 1 and list 2. And let's go ahead and enter in the data from our chart. Okay, now that we have the data entered into list 1 and list 2, we're going to go back to our stat. We're going to arrow over to calc and down to linear regression. Pressing enter there and enter again, we're going to get our model for this data. So it looks like the regression line here would be y equals 0.00049x plus 68.9. Okay, so there's our linear regression model here. All right, part B of this problem now asks, based on an income of $7,100, what does the regression equation predict for the life expectancy in Ecuador? So this is going to require us to take 7,100 and substitute it in for the value of x and come up with what y, our expected life, or our life expectancy should be. When we do this, we're going to end up getting a value of 72.88 years. You can see here from the chart in Ecuador, it's actually calculating out to be the life expectancy of 77. All right, how much does this differ from the actual value? Well, this is called the deviation. So the actual value was 77, and the predicted value was 72.8. So we're going to take 72.8, and we're going to subtract that from 77, and this comes up to be 4.2 years. All right, finally here in the last part of this problem it says, would you expect a country with a strong public health system to be above or below the regression line? Explain your answer. So I'm going to leave that one up to you, and we'll see you tomorrow in class.